Wow, I want to show you how to calculate power dissipated in an electric circuit. Now, there's a question on the board which is a Jamb question 2004. Now, the question is a very simple question that we are going to solve right away. But before we solve the question, I want to kindly ask you to subscribe, to share, and to like our videos. And in case you have any question and to ask, or you have any comment, please feel free to send a comment to us. Now let's begin solving the question. The question says, in the diagram above, the ratio of the electric power dissipated in the 6 ohms and 3 ohms resistors respectively is. So these are the options to that carries the answer, the options that carry the answer to this question. Now we'll go right away to solve the question. Now, the first thing you need to do, I always say, is to check what the question says. Now, or you bring out your parameters first, but let's look at the question. Don't forget, what we're asked to calculate is the ratio of the electric power dissipated. So what you ask yourself first is, what is the formula for power? Now, what is the formula for electric power? Mind you, this is electric power. This is very, very important. Electric power. What's the formula for electric power? Now, the formula for electric power is electric power. That's electric power because this is a circuit, this is an electric circuit. So electric power is given as, that's P, is given as I square multiplied by R. Now, this is what you have. So what you now do next is, since this is the formula, do I have power? Do I have current here? Because that means I need current to calculate the power in the 3 ohms resistor and the 6 ohms resistor, because that's what they asked you. In the 6 ohms resistor and 3 ohms resistor, you are not asked to calculate the power dissipated in the whole of the circuit. No, you are asked to calculate the power here and the power here. So this is a different question. So what you do next is you will begin solving that. So that means you need to calculate the current here. Since I don't know the current, I need to find the current in the 3 ohms resistor and find the current in the 6 ohms resistor. And then from Ohm's law, we know that current is going to be equals to V over R. Why? Because V is equals to IR. So if you make I the solving formula, you have V over R. Now, so what we're going to do is this. Since that's what we know that current is calculated, that's how you calculate current. So what we'll do is this, we'll begin to say current, let's say current I in the 3 ohms resistor is going to be equals to, we have I equals to V over R. So therefore, we're going to have I is going to give us V. The V is this 12 volt. So 12 volt over R. Sorry, over the 3 ohms here, since we're talking about 3 ohms, over 3. So we're going to have 12 divided by 3 is going to give us 4. So the unit for current is amperes. So 4 amperes. Then the next thing, since we have calculated the current there, we need to calculate the power dissipated here. So we already know that power dissipated in the 3 ohms resistor is going to be equals to I square multiplied by R. So that is to say that the I here is already 4 squared times the R. Don't forget this R times 3, because that's the resistor we are using. So this is 4 times, that's 16. 16 times 3 will give us 48. 48 watts. Power is measured in watt, so 48 watts. So the next thing to do is to calculate the current. Also have current in the 6 ohms resistor. Current in the 6 ohms resistor is going to be I is going to be equals to V over R, which is the V is 12, so 12 over 6. 12 over 6 is going to give us 12 divided by 6 is 2 amperes. So we have the power. So power dissipated, just like this, is going to be equals to I square R. So we have I square, which is equal to I square, that is our 2 here, 2 square times 6, our 6, that's 2 square is 4, 4 times 6 is 4 times 6 is 24, so we have 24 watt. So this is what we have. So we calculated the current here and the power here, the current here and the power here. So what we need to do is to find the ratio of the power. The ratio of the power is going to give you, don't forget the question says you follow the order, dissipated in the 6 ohms and 3 ohms. So in the 6 ohms, that's when we got this 24. So 24 will come first, and then what we are going to also have, don't forget, if you include the watt, they will cancel out. 24 watt is going to be is to 24 watt is to 48 watt. So if you calculate this, 24 can go here, this will cancel, this will cancel. 24 can go here 1 time, and then 24 can go here 2 times. So your answer is 1:2. 1:2 is option B. So option B is our answer, 1:2. So this is the solution to this question. Thank you for watching, and please don't forget to like, to share, and to subscribe for more videos. And please feel free to send your comments to us. Thank you.